Okay, so let's do this one kind of quickly. So the idea, this is going from a cone to a sphere of radius 200. That's what these tell us. It's going from the right cone to a sphere of radius square root of 200. In the xy plane, this bound says we're only looking at the top part of a circle. This says we're only looking at the right part. So it just says we're integrating in the first quadrant. Okay, so the fact that it's going from it's going along a cone up to the sphere of radius square root of 200, says rho goes from 0 to the square root of 200. The fact that it goes to the cone, that is inside of the cone, tells us phi goes from 0 to pi over 4. And then the fact that it's in the first quadrant tells us theta goes from 0 to pi over 2. And then don't forget to just always write down the rho squared sine phi d rho d phi d theta. And then this part right here, rho sine phi rho sine theta sine phi, that's y in spherical coordinates, and rho cosine phi, that's z in spherical coordinates. Okay, now this is a tedious integral to do, but nevertheless, one that is straightforward. So now we're going to do this, and we're going to do this UV, this switch to UV coordinates. So in a problem like this, the first thing that you want to do is to sketch the region that you're given in the XY plane. So this is what the region looks like in the XY plane, and this is the boundary of the region, the blue part, the green part, and red part. I'm just going to use that to sort of color code what we're going to look at. Okay, so the equation, so now that we've sketched the region, the next thing that we want to do, usually for something like this, is to get an equation in the XY plane for the boundary. So for this blue part, the equation for this is y is equal to x divided by 9. That's because the slope of the line is 1/9, and it goes through the origin, so the y-intercept is 0. For the green part, the equation is y is equal to 9x, and for the red part, the equation for this, well, we know the slope is going to be -1 because 1 minus 9 over 9 minus 1, that's the slope. So the slope is -1. And now we need to figure out what the y-intercept is going to be. So we'll just write b for now. So if we plug in the point, let's say x is equal to 1 and y is equal to 9. This says 9 is equal to minus x plus b. Okay, so this means b must be equal to 10. If 9 is equal to minus x plus b, if 9 is equal to minus 1 plus b, then b is equal to 10. Now we want to figure out what each of these are going to be in the UV plane. And the way that we do that is for each one of these equations, we're going to use our expressions for x and y up here. So in each one of these expressions, we're going to plug in our expressions for x and y. So y is equal to u plus 9v. So this first line, the blue boundary piece, this is u plus 9v is equal to x over 9. So this is going to be u plus, oh boy, that's a u actually, u plus v over 9. Okay, so what this says is 9v is equal to v over 9. In other words, v is equal to 0. Because if u plus 9v is equal to u plus v over 9, that means 9v is equal to v over 9. And the only way that happens is if v is equal to 0. Okay, now for the green boundary, again, this is u plus 9v is equal to 9 times x. So this is going to be 81u plus 9v. Okay, so this says u is equal to 81u. So in other words, in the UV plane, this corresponds to the line u is equal to 0. And finally, for this red piece, okay, u again, u plus 9v is equal to minus x. So this is minus 9u minus v plus 10. Okay, And now what happens if we solve this, if we solve for v, well, you add 9u to both sides. So you get 10u is equal to minus 9, sorry, 10u is equal to minus 10v plus 10. Or in other words, v is equal to 1 minus u. Okay, so now if we draw these in the UV plane, this is what we're going to get. So let me draw the UV plane. So typically V is the vertical axis and U is the horizontal axis. So this is U, this is V. Okay, so now the blue bound corresponds to V is equal to 0. That would be this line right here, V is equal to 0. The green bound corresponds to U is equal to 0. Oops, I got that backwards, didn't I? So the blue bound corresponds to V is equal to 0. So the blue bound corresponds to V is equal to 0. That would be along the U axis. Okay. The green bound corresponds to U is equal to 0. So that would be this part right here. Okay. And then the red bound corresponds to V is equal to 1 minus U. That's this bound. That's that line. So in other words, the region that we're integrating over is this triangle right here. Okay. So in UV coordinates, let's call this region R. So we're going to be integrating over the region R. Okay. And we're going to write this in UV coordinates. So U, for every fixed value of U, V is going to go from 0 up to 1 minus U. So this is going to be V equals 0 to 1 minus U. And then U is going to go from this point to this point. That's U equals 0 to 1. U equals 0 to 1. Okay, now we have to multiply. Remember, here we have to multiply by the Jacobian. So the Jacobian of the transformation, or the absolute value of the Jacobian of the transformation is this. So you're going to form a matrix, and the first entry is going to be the partial derivative of x with respect to u. This is going to be the partial derivative of x with respect to v. This is the partial derivative of y with respect to u. And this is the partial derivative of y with respect to v. And now you're going to multiply it by the absolute value of the determinant of this matrix. Okay, so for our particular problem, the partial derivative of x with respect to u is 9, and the partial derivative of x with respect to v is 1. So this is 9. That's 1. The partial derivative of y with respect to u is 1, and the partial derivative of y with respect to v is 9. So this is going to be 1, 9. Okay, so the determinant of the Jacobian is 81 minus 1, which is 80. So we'll do 80. And then dv du. Okay, now we just need to change the function that we're integrating. This is the function that we're integrating, x minus 10y. Okay, so x is 9u plus v, so we're doing 9u minus 10y. So the u part is going to be 9u minus 10u, so that's going to be minus u. Okay, and then for the v, it's v minus 10 times v. So v minus 90v. So this is minus 89v. Okay, let me just double check that. 10 x minus 10y. So the u terms, 9u minus 10 times u. That's going to be minus u, and the v terms, v minus 10 times v. That's v minus 90v. That's minus 89v. Okay, and now this is an integral that you know how to do. So might be tedious, but you know how to do it.